Hello students, today our topic is glycolysis. As we all know, glycolysis is a very famous reactions. From by these reactions, glucose is converted to the pyruvate, and actually it has the 10 reaction steps. And this is the basic reaction that is represented here. That is, this is a cyclic structure of the glucose. Actually, it is known as the glucopyranose. That is the cyclic formation of the glucose, and it is pyranose just because of the presence of the six carbon as well as six membered ring, and among the in the presence of the five carbon is participating in the ring formation along with the oxygen moiety. And actually glucose have the six carbon, and among the six carbon only five are here participating in the formation of the new ring. And it is anaerobic reactions in cytoplasm, and by these reactions glucose is converted to pyruvate. Now glycolysis actually have 10 steps. In case of the step 1 to 5, we are termed as the energy investment phase, just because of the 2 ATP is utilized in these phases. In phase 1, phase 2, 3 and 4, this is consist of the first portion of the glycolysis. And in phase 1 and in reaction 3, that is marked in this reaction 1 and 3, 2 ATP is converted to ATP, that is where 2 ATP is utilized. And in this first portion of the glycolysis, that is actually termed as energy investment phase, the glucose cyclic structure of the glucose molecules is converted to two molecules. The first one is the dihydroxy acetone phosphate, and second one is the glyceraldehyde 3-phosphate. Now here the conclusion of the whole process is summarized at the in this page. That is, 2 ATP molecules are hydrolyzed and the 6 carbon glucose molecule is converted into 2 carbon segments. Now whenever we go through about the step 6, 7, 8, 9 and 10, it is actually termed as energy generating phase. Means ATP molecules are synthesized by these reactions. Now from the step 4 we can get the two molecules of actually it is termed another form of the triose. Dihydroxyacetone is an example of the triose, and whenever a phosphorylation is there, it is termed as dihydroxyacetone. It is converted into glyceraldehyde 3-phosphate, and the reaction is marked as the reaction number 5, and this is actually isomerization reaction. And we get after this fifth step two molecules of glyceraldehyde 3-phosphate. Whenever this glyceraldehyde 3-phosphate undergoes for the further reactions, it utilizes ADP molecules and new ATP molecules are synthesized along with the production of NADH, and at last it is converted into the pyruvate. Sorry, as the ATP are synthesized in these reactions, that is why these are termed as the energy generating phase. Now these are the common enzymes that are involved in the glycolysis. Now the types of the enzymes are carboxylase, and the types of the reaction they involve, that is addition of the carboxylate C++. Second one is the decarboxylase, and the reactions of involved decarboxylase, that is removal of the carbon dioxide. Third one is the dehydrogenase, and dehydrogenase enzymes are actually they are responsible for the removal of the two hydrogen atoms. And fourth one is the isomerase. We all know that all the isomerization reactions are take place by the presence of the isomerase reactions. And fifth one is the kinase, and it is responsible for the transfer of the phosphate moiety. Now go for the reactions. Now at the step 1, the glucose ring that is 6-membered glucopyranose ring, is converted to glucose 6 phosphate by the phosphorylation reactions and by the help of the hexokinase enzyme, and ATP is converted to ADP. This is all about your step 1, and it is begins with the phosphorylation of the glucose, and glucose is converted to glucose 6 phosphate. Now go for the step 2. In the step 2, glucose 6 phosphate is converted to phosphohexose in the presence of phosphohexose isomerase converted into fructose 6 phosphate, and this is actually isomerization reactions. Here the structure of the glucose is the 6-member glucopyranose ring, but in case of the fructose it is actually the fructofuranose structure, and fructose 6 phosphate means 6th position of the fructose ring is hydrogen is replaced by the phosphate moiety, and this is also a isomerization reactions. In the step 3, fructose 6 phosphate is converted to fructose 1,6 bisphosphate, means here in the we have the term in biochemical pathways that is bis. Actually bis indicates the 2, so fructose 6 phosphate is converted to 1,6 bisphosphate, means 2 phosphate moieties are entered in the molecule, and actually 2 hydrogens are replaced by the phosphate moiety, and ATP is converted to ADP, and actually this is a phosphorylation. And so the enzyme involved in this reaction, that is phosphofructokinase, and step 3 is actually the phosphorylation of the fructose 6 phosphate and production of the 1,6 bisphosphate, but along with the production conversion of ATP to ADP. Now we will go for the conclusion of the first these steps. Now at first we have to conclude that 2 phosphate groups are added along with the isomerizations of the 6-membered ring into a 5-membered fructose ring, and along with the production utilization of 2 ATP molecules. Now go for the next step, that is step 4. Step 4 includes the cleavage of the fructose ring into dihydroxyacetone phosphate, and along with it is converted to glyceraldehyde 3 phosphate and dihydroxyacetone phosphate, means 2 molecules of triose is actually synthesized, means the blue mark portion, that bond is broken and the cleavage is occur, and here 2 molecules are synthesized, 2 different molecules are actually synthesized. First one is the dihydroxyacetone phosphate and second one is the glyceraldehyde 3 phosphate. Just because of the dihydroxyacetone, it bears a phosphate moiety, that is why it is a phosphate, and glyceraldehyde carries the phosphate moiety in its 3 position, and hydrogen is replaced by the phosphate moiety, that is why it is termed as glyceraldehyde 3 phosphate. Now go for the 5th step. This is actually isomerization reactions, as I already told that dihydroxyacetone phosphate is converted into another glyceraldehyde 3 phosphate moiety. So from these reactions we actually get 2 molecules of glyceraldehyde 3 phosphate moiety, and from step 1 to 5 actually 2 ATP are used for the production of glyceraldehyde 3 phosphate moiety. Now this is the step 6, where the dihydroxyacetone phosphate is converted to glyceraldehyde 3 phosphate in the 5th step. So 2 molecules of glyceraldehyde 3 phosphate now go for the further reactions. So glyceraldehyde 3 phosphate dehydrogenase enzymes convert the glyceraldehyde 3 phosphate into 1,3 bisphosphoglycerate, means another hydrogen moiety of the compound is also go for conversion and replacement by the phosphate groups, and this is actually oxidation as well as the phosphorylation reactions. We can see the right hand CHO group, that is aldehyde group, For the oxidation, it is converted into COOH group. After that, the H group is replaced by the phosphate group along with the production of NADH. This is all about step 6. Now, in case of step 7, the phosphate group present in the structure is transferred. Actually, the phosphorylation that is happened in the previous step, we can see in the previous step phosphorylation is occurred in the first COOH group. Then in the step 7, that phosphate moiety is transferred by the phosphoglycerate kinase, and 1,3-bis phosphoglycerate is converted to 3-phosphoglycerate along with the production of ATP, and this is actually a phosphate transfer reactions in the presence of kinase enzyme. Now go for the step 8. The phosphate group is isomerized to a new position in 2-phosphoglycerate, and that 3-phosphoglycerate is converted into 2-phosphoglycerate. This is also isomerization reaction, so you can see that the phosphate moiety is replaced into the second carbon. That is why 2-phosphoglycerate is the compound, and the enzyme involved for this reaction, that is phosphoglycerate mutase. Now in the step 9, water is lost, that is a dehydration reaction, and then finally the phosphoenol pyruvate is synthesized. 2-phosphoglycerate in the presence of enolase enzyme is converted to phosphoenol pyruvate. So at last, the phosphoenol pyruvate in the presence of pyruvate kinase, the phosphate moiety is transferred and it is converted to pyruvate along with the production of ATP. Now in the step 7, we can see that one ATP molecule is synthesized, and in the step 10, that is the last step, another ATP molecule is synthesized. Now go for the conclusion of the glycolysis, that 2-glyceraldehyde 3-phosphate units are converted into 2-pyruvate units in the phase 2 of glycolysis. Overall, the energy generating phase forms 2 NADH and as well as 4 ATPs. Now 4 ATPs means 2 into 2, 4 ATP means 2 molecules of glyceraldehyde 3-phosphate involved in the reactions, and for each molecule you can get the 2 ATPs. Now the calculation is 2 into 2, 4 ATP molecules. 2 ATPs are used in the phase of 1, means the first phase of the glycolysis, and 4 ATPs are made in phase 2 of the glycolysis. So as a net result, we in this synthesis of 2 ATPs from the glycolysis, the 2 NADHs formed are made in the cytoplasm and must be transported to the mitochondria to join the electron transport chain and make ATP. In the lower portion, you can see that the whole reactions for the glycolysis, and glucose is converted to pyruvate along with the production of 2 ATP. Now this is the overall reactions for the glycolysis. Okay, thank you.